All right, here's our word problem. We can put this math with some context. This is your real life situation that we always wonder, when does this happen in real life? Well, here it is. All right, we've got Malia. Oops, didn't mean to do that. There we go. All right, so Malia has $500 to purchase water bottles and pairs of socks for a fundraiser for her school's cross-country team. She needs to buy a total of at least 200 items without buying too many of just one item. What graph shows the possible numbers of water bottles and pairs of socks that Malia should buy? So we always start out with defining our variables, and we can look to the question to help us do that. What do they want us to answer? We want to know the possible numbers of water bottles and pairs of socks. So let's let x equal number of water bottles and let's let y equal number of pairs of socks. So this is just really helpful. Anytime we use an x, we understand what we're representing with that. Anytime we use a y, we understand what we're representing with that. And if we were to show our work to anybody else and we had x's and y's in the context of a problem, they want to know, well, what are these x's and y's you're using? You can say, look, right here, I defined my variables because Mrs. Youngberg taught me how to do that, right? That's right. Okay, now we're going to write a system of inequalities. So when you're writing your equations, inequalities, whatever the case may be, start by looking for total numbers, all right? So Malia has $500 to purchase, and over here we can see what these items cost. So I think the $500 is going to go with the cost of the item. So let's write an inequality for the cost of things, like the price. So the water bottles cost $2. So she has to spend $2 for every water bottle she buys. In addition to that, the pairs of socks are $3. So $3 times every pair of socks that she buys. And she can only spend $500. Now, does she have to spend exactly $500? No, she could spend less, but can she spend more than that? She cannot. So we're going to say that 2x plus 3y, the money she's spending, has to be less than or equal to 500. Okay, then we look back at the problem. What else could we, again, when you have an inequality with two variables, oftentimes, and if you're trying to find out two different things, you're probably going to need a second inequality so we can solve both. She needs to buy a total of at least 200 items. So if you take her number of water bottles plus her number of pairs of socks, that gives us the total number of items that she's buying. And she has to buy at least 200 items. That gets tricky. When we see at least, a lot of students want to say less than because they see the word least. But at least means that that's actually the least amount you can buy. She can buy 200 or more. So our inequality has to be greater than or equal to 200. So we just want to be careful with the wording and make sure we end up with the correct inequality. All right, moving on to step 3, we are going to graph the system of inequalities. We could do this two ways. You could solve both inequalities for y, then you have slope-intercept form. I think that gets tricky when you're dealing with a graph where your axes are not counting by 1. The y-intercept, we probably could hopefully find it, but it's that slope. Like if you were to solve this inequality right here for y, you would have y is greater than or equal to, this x would get subtracted to the other side, so you would have a negative x. So your slope is -1. So if I'm at 120, I have to go down 1 to the right one, down 1 to the right one, down 1 to the right one. It just gets, our graph isn't that detailed to do that slope. So another way to graph lines is using your intercepts. And I think intercepts can be a really nice way to go if we just remember that that's a possibility. So let's take our 2x plus 3y is less than or equal to 500 line. Let's find the x-intercept. X-intercept is where you keep the x, you plug in a 0 for the y. So I'm going to do that in my head. I'm going to plug in a 0 for the y. 3 times 0 is 0, and I know that term's going to simplify away, so I'm just going to carry down is less than or equal to 500. Maybe that's being lazy on my part of not showing plugging in the 0, but we've seen that enough that I think you guys know what we're doing. Let's keep solving for x. So x is less than or equal to 5, and actually, we don't even need the less than or equal to. If we're finding an intercept, it will equal this value. 500 divided by 2 is 250. So we have an x-intercept of 250. So if we go to the graph on the x-axis, here's 240, here's 280. We're counting by 40, so halfway in between would be 260. So like right here would be 260, which means 250 is going to be halfway between 240 and 260. So there's my x-intercept of 250. Let's find the y-intercept. That means you keep the y and put in a 0 for x. So if we put in a 0 for this x right here, that term simplifies away, leaving us with 3y equals 500. Divide both sides by 3, and we get a y-intercept of 166.7. So we definitely are going to do some estimating on where that point is. Here's our y-axis. It's a y-intercept, so it's going to go up here. Here's 140, 160, so we're counting by 20s. 180, so halfway between is 170 right there. So it's going to be between 160 and 170, maybe just a little closer to 170, but that's about as detailed as we can get with that. The inequality has an or equal to line, so solutions will be on the line, so we're going to draw in a solid line for this. And if you have a straight edge, it's going to make it a little bit easier. I was close. There's my solid line. And then shading. Because we have not solved for y, it's tricky to see what the shading is going to be. So I want to show you guys how you can do a test point. I don't know if we did that in another video or not. I'm going to just choose a point. And honestly, a really easy one to use is 0, 0. I want to know if 0, 0 is a solution. So let's plug in 0 for x. Let's plug in 0 for y. Let's see if that is less than or equal to 500. So 2 times 0 is 0, 3 times 0 is 0, 0 plus 0 is 0. Is that a true statement? Is 0 less than or equal to 500? Because it is, that means that 0, 0 is a solution. So I have to shade on the side where 0, 0 is. 0, 0 is below my line, so we are going to do shading below the line for this part of our inequality. Okay, now let's get our other equation going. We have x plus y is greater than or equal to 200. Let's find our intercepts. So the x-intercept, keep your x, plug in a 0 for y, so we get x equals 200. We go to our graph on the x-axis, here's 200 right there. Our y-intercept, keep the y, plug in a 0 for x, so that just leaves us with y equaling to 200 as well. 200 on our graph is actually up here. It's the highest point. It's not labeled, but it would be that next point up from the 180. This is a or equal to line, so solutions will be on the line, so we're going to draw a solid line. So grab a straight edge, see if you can draw it better than me. Oh, mine was pretty good actually. Now, where's the shading? Are we shading above or below this line? So let's do another test point. Can we use the same test point that we used on the last one? Sure. We just want to know, and you could do this with any point. You just plug in an ordered pair. So if you have a true or false statement, if you have a true statement, you have found where the solution set is. If you have a false statement, then the solution would be on the opposite side of the line. So let's plug in a 0 for the x, a 0 for the y. Is that greater than or equal to 200? 0 plus 0 is 0. And 0 is not greater than or equal to 200. So that means that 0, 0 is not a solution. So if I go to, we're on the blue line, 0, 0 is below the line, and that's not a solution. So that means we're not shading below, we have to shade above the line. So when we shade above the line, go to the blue line, put your pencil on the blue line, go straight up. That's the region we're going to shade. Here I'm on my blue line, go straight up. That's the side we're going to shade. So I'm going to get my highlighter. Maybe I'll highlight in blue this time. Ooh. Okay, so remember the solution set is going to be any place where the shading overlaps. Maybe I can come in with a different color to make that more obvious. So here is just this little region right there. That's our solution set. So let's interpret this answer. What does that mean? All right, here's our interpretation. Leah can buy any combination in the shaded region. So again, I end up shading it in green. Any point in the shaded region would give her a combination that would meet the criteria we set up with our inequalities. But she should be careful to choose the number of items she expects to sell. For example, she could buy 250 water bottles and 0 pairs of socks, I should say but a more even distribution might be preferable. So it might be more likely that she sells a combination of the two versus all water bottles and no socks. All right, last question. I know this has been a long video. Use the graph to determine if Malia can buy 75 water bottles and 100 pairs of socks. So let's look at the graph and see where that is. So the x's, remember we defined our variables, are representing our water bottles. So here's about where 75 water bottles would be. Oh, and I already forgot how many, and 100 pairs of socks. So if she sells that combination of 75 water bottles and 100 pairs of socks, that's right there. Is that in our solution set for the system of inequalities? That's in one shaded region, but is it in the overlap where the solution set is of both inequalities? It's not. So no, she cannot do that. And let's just write a note. 75, 100 was not in the overlap solution set. Just so if we go back and look at our notes, we'll understand why we're saying no.